So this is the project I decided to do. It's sort of like an arcade game where you have to choose the right color. If you ever played if you've ever gone to an arcade and played the game where the color swoops around the circle and you have to hit it at the right time when it comes to a certain spot, it's similar to that, except there's only going to be one LED, and instead of going around anything, it's just going to be going through different colors, and you have to stop it at the right color. Okay, so I kind of explained it already, but here's how the game works. So first, the program is going to choose a random color, and then it's going to cycle through it's going to show you that color, and then cycle through complete other random colors for a given amount of time, which is also randomly chosen. After that point, it's going to repeat the original color. When it does this, what you need to try to do is press the button as quickly as possible once you see your original color repeat. It will not repeat in this sequence. Okay, and then if you do that, if you're successful in doing that, then you will win, and you'll get a green LED blinking. If you're not successful in doing that, you're going to get a red LED blinking. Now, it's going to give you instructions through the serial monitor, but you'll be able to see that a little bit later. So now, if you want to get into how the code works in a little bit more of a systematic way, if the pictures weren't working for you, then so this is the pseudo code. So we're going to choose a random color and show it to the player. Once that's done, we're going to choose a random number of fake colors to show. So how many fake colors are we going to show in that series? Then we're going to cycle through all those fake colors. Like we're going to make a new fake color those many times that we chose randomly over here. Of course, it's going to have some type of range. And then we're going to say a certain amount of time, and after that, we switch to the next color. If the player presses the button during this time, they lose, because that means they've pressed on the wrong color. However, and then after that, we're going to show the original color after those random number of fake colors. When the original color is shown, if the player does not press the button, then they'll lose because they didn't press it for the color they needed to. But if they do press it, then they win. And the amount of time they have to do this is completely related, or is the same as the the amount of time it takes to cycle through each different fake color. Okay, and so let's look at the circuit. The circuit is very simple, and if we zoom in, we can see that we have our RGB LED, which we discussed in a previous tutorial, and we have them connected to our pins, which you can't really see. You can see it in the previous slide, although it was not really necessary. You'll see that in the code as well. So we have our red, green, and blue all connected with our resistors to our RGB LED. And remember that the RGB LED is nothing more than a red, green, and blue LED just stuck inside the same package, and they all have the same common ground. Okay, and the next thing we did is we connected up our button. So the way this push button works is these two and these two are always connected, regardless of whether the button is pressed or not. Now, when you press the button, what happens is these two and these two get connected. Okay, so those two terminals. So if you look at the circuit here, what happens is this goes and connects to our digital pin. That's what we're reading as input. So when it's not pressed, what's going to be connected is we're going to be connected to ground through here and through the resistor into ground. However, when the button is pressed, the power is going to flow into here, and since now these two are connected, it's going to connect into here, and since these two are always connected, it kind of makes this the shape over here and connects to our input, and that way we're going to get our 5-volt when it's pressed and 0 volts or low when it's not pressed. Okay, so if we go ahead and look at it now, you can see the functionality that I was trying to explain in the slides. So if I start the simulation, and we need to open our code because we want to see the serial monitor, since that's what's going to be giving us instructions. So it says press any button to start the game, and press the button. There's only one button. Then it shows us our color over here, and then gives us some instructions. So I can read them out. It says look at the color on the LED and remember it. When you see that color, quickly press the button. Do not press the button on the wrong color because it's going to be cycling through them. Remember. And if you remember the color and understand the rules, press the button to continue the game. Okay, so I got the colors, kind of like a really light cyan. So click the button. Nope. No. No. Yes, that looks to be it. Oh no, I guess I was wrong. So let's try again. Sometimes the colors can be pretty similar, and we'll get into how different they are in the code. So that's one of the tricky things. You have to really look for the color and make sure you're clicking the right one, and also clicking as quick as possible. So again, I was wrong, or I clicked a little too late. So you really got to be quick about it. Um, and that also can be changed as a parameter. But if we go ahead and start again, uh, it's sort of this light green. And I think that would be it. Yep, there we go. So we see that we've got it well because we won the game because we have the green LED blinking, and we can also see that we have it says you won over here. So now if we want to look at the losses we had, the loss case scenarios, which I already demonstrated a few, but we can get into it further and I can explain it. So one of the simple ones is if you click on the wrong color. So I click on the wrong color, it says wrong color down here, and you get the red blinking. Now the other situation is that you completely miss it. You miss your color, so you didn't click it when the true color came up. So you can just sit back and wait until that happens. And then if you get a message saying you missed it right down here, and we get the red LED blinking signifying that we lost the game. So that's our little game over here. And now we can go ahead and look at the code. Okay, so in the code we have a couple parameters, four to be specific. Let's go through them each one of them because these are the important variables realistically, or at least the variables that control the behavior of the program in a meaningful way. Okay, so closeness. This basically tells you those fake colors that we're generating, how close can they be to the original color? So for each red, green, and blue value, how close is it allowed to get to the not the original, the correct value? So by default, this is set to 25. And if you just remember that the entire RGB spectrum goes from 0 to 255, so just hopefully gives you some scale. And time between colors, this is how long it takes to cycle through all the different RGB fake RGB lights. So between the time it takes to switch through them and cycle through them to go to the next one, that's this time. And it's also the time that how quickly you're going to have to click the button once you see your color. By default, this is 900 milliseconds. Next is duration. This specifies how many fakes in total there's going to be. So how many fake LEDs we're going to show before we show you the real one. And this is the max, this is not the actual value, but this shows the maximum. And by default, this is 10. And the minimum is 3, but you don't need to change that just because it's realistically you'd at least want 3 to happen before you click something to keep the game interesting. And then the last one is debug, and this is fairly simple. If you set it to true, then it's just going to give you some more serial monitor statements, which are basically going to tell you the color, the RGB value color of the correct color, as well as when the color is generated, each fake color as well. Okay, so if we go ahead and we'll go through the rest of the code, these variables all have comments that's properly explain what they are, but I can go over them again. This is just the pin values of where we've connected the RGB LED. This is where we've connected the button. This stores the correct color. So the color we're looking for to press, and that would be the first color as well. And it has default values of 300, so that in the function where we generate random colors, and remember how they can't be too close to each other. That's why these values are 300, just way above 255. And ideally, you'd actually want to say 255 plus whatever this closest value is, just because that way, if you increase the closest value, then it'll still work correctly. And in fact, that's something we can do right now. If all we have to do is just move this below closeness, so we can use it. And then instead of saying 300, we can say 255 plus closeness. Okay, and then we can copy that over to all different ones. And the reason we need to do this is because that way, when it's generating a new value, the original, the first color for it's generating for this correct value, you need to have something to compare it to. Otherwise, it's trying to compare it to a value that doesn't exist, and that's going to cause problems. Okay, and this just specify. This is just an intermediary thing. In fact, it's not even necessary anymore because, as you can see, oops. With those it's the variable is never used. It was actually a relic of an old system that was being deployed, but we no longer need it, so we can delete it. This just declares this declares the RGB LED as an output and declares the button as an input. And this is pretty cool. So we use random a lot in the program, and random actually needs some sort of seed to create all the other randoms from. So once it gets a truly random seed somehow, it can start to create all those other pseudo random numbers. And this true randomness is very hard for a computer to get. But luckily, since we're working with such low-level electronics, an easy way to get that is by reading a pin that has nothing connected to it. because that way it's just going to read the electrical noise, and that's what we're doing. We're reading pin 0, which has nothing connected to it, and it's just going to be reading the electrical noise in the environment, and that's a pretty random number. Okay, and then we begin the serial monitor, of course. And what we do here is we say we just give ourselves 20 lines to look like the serial monitor was cleared. Because in Tinkercad, what happens is that it keeps the values from the last time you ran the program. So just for Tinkercad specifically, it gives us 20 new lines. Okay, so now we can move on to all our other functions that are used in the main loop that call upon these functions. So this function, set color, does exactly what it says. It sets the color of the RGB LED based on red, green, blue values. This function is going to hold the program flow until that button is pressed, and we use that as you saw in the simulation, mostly for the instructions. So when the person is done reading instructions and memorizing the LED, they can move on. This function is pretty important. It's to get the random color, and you'll notice this asterisk beside here, and that actually means a memory address. We haven't worked with those before in previous tutorials, but what it's doing is it's going to give you a memory address rather than the value. Okay, so it's giving you, instead of giving you the value of whatever variable, it's going to give you where that variable is stored in memory. So that way, and we need to do this because we're trying to return a list, and in C++, that's not something you can do. You're not allowed to return lists. So we return a memory address instead, and from that point, we can access every single element in the list. You'll see this more down in the main loop. But if we enter this function, you can see that over here, this is the part that making sure that we're not too close to the original color. You can see that we're comparing for closeness by doing a subtraction, checking the difference. And then if we're below half of 255, then we add 25 to it, or add closeness to it. And if we're above, we subtract it. So that way we're always that far away from the correct color or the first color. And then we just assign that to random color, and then we finally return random color, which it's a 3-element list. And we're not actually returning the value, however, we're returning the memory address. Okay, this function is very similar to wait for a button press, except it actually is waiting for a certain amount of time. So it's like a delay, and if you press a button within that delay time, it breaks out of that delay and also returns true that you have pressed the button. If you don't press the button and the entire delay time finishes, then it's going to go ahead and return false. This is used to detect if you press the button during a certain color. Next are our win and fail functions, and those are just going to blink red or green corresponding to whether you've won or lost. And now we enter our main loop. So this is in the beginning. This is a one-time process. We generate the number of fakes that we're going to use. And then we give ourselves some instructions. Let the player press the button to continue. Then here we generate the first color or the correct color. And we show this, and over here we show it to the player. If it's debugging, we're going to show what the value of that was. And then we're also going to give them all the other instructions and wait for them to understand and accept and continue. Okay, and these delays are just here because at the end of every time a button is pressed, just because when a button is pressed, it can often have a little bit of lag before the input detects that it's going off. So that's why we're here, so we don't accidentally click on a color that we didn't mean to. And this is really this is the main loop for all the fakes. So this is going to go through each fake color. It generates it right here. It generates a fake color and then assigns it that color to the set function. And this is the memory address thing that we were talking about. You can also see it up here. You can see it over here, but I think it's going to be a little bit easier to talk about over here instead because we're not using the loop, so it makes things a little bit less complicated. So what we're doing is we're getting P, and P is storing the memory address of that list, the first index. So just this value P is going to store the first index of the random list of colors. In this case, since we're going in the order of red, green, blue, that's going to store the value of red. Now, if we want to get to the next index in the list, all we ever do is add 1 to P. Then we hop on to the next memory address, and then it goes to green, and same thing for blue, but plus 2 because we're hoping 2 over from the relative position of red. Hopefully that makes sense. I know we haven't discovered in other tutorials, but it's a concept you can look up, pointers in C++. And again, if we have debugging on, we're going to print out the value, that RGB value of the random number we have just generated over here. Then here's our special function that waits for a certain amount of time, but breaks if the button is pressed and returns you whether the button is pressed or not. If they press the button at any point during any of these fake colors, we know that they've failed because we are not showing the original color. We're only showing fake colors. And so we call the fail function. Now, if they make it past all the player, if they make it past all the fake colors, then we go ahead and set the original color. and we can see we're saying correct color. That's what we stored before the first time. And then now what we're saying is if they don't press it within the allotted amount of time, then they've missed it and then they fail because they didn't press it in the amount of time in the short time required, in the 900 milliseconds, at least by default. However, if they did press it within those 900 milliseconds, then you know that they've won because they pressed the button on the correct color. So that's it. That's the entire code. It's definitely not simple, but it's pretty small and pretty elegant for what it's trying to do, and it makes a pretty fun game. To challenge yourself, if you're trying to build this, what I'd like you to do is use other sensors to be able to go ahead and change all four of these parameters. Okay, so for all these analog numbers like closeness, time between colors, and duration, you can use a potentiometer to go ahead and choose that value, and you're going to have to scale it because a potentiometer only goes from 0 to 1, 0, 2, 3, and that might not be the values that are going to be appropriate for these things. So that's going to have to be scaled. Okay, and finally, debug can be used with a slide switch, with this state being false, and if this the simulation, and this state being true. Okay, so that's what I want you to try to do if you're going to try to recreate the circuit, is make all these parameters editable, editable in the circuit itself, so no one has to look at the code or change it. Okay, so that way the players themselves can choose the difficulty of the game. And another side note is if you are testing this, if you're making it yourself, something good to do, or if you're just cheating, I guess, is to increase the closeness value. That way, by increasing the closeness value, that's going to increase how far apart or how distinguished the different colors are going to be, so you can't mess up easily, and you'll be able to understand what's going on more easily. Increase the time between colors. That way, your reaction speed does not have to be super quick, and you can take your time to understand what's going on. And lower the duration so you don't have to wait for like 20 or in by default case 10 colors to pass for you to finally get to the correct color. Okay, so hopefully you understand how this works and you have the tools now to make this circuit and in fact make it better. Okay, till next time.